All right, we are starting our new unit on solutions today, and the first thing I want to talk about is something you may have seen before. Does this look familiar to you guys? Yes. This drawing up here in the corner? Yep. Hopefully it does. Okay, you guys remember what it's called?
It's like the lipids and all that.
The lipid...
Barrier.
Close. Okay, you've got a layer of lipids here and a layer of lipids here, so this would be the lipid... bilayer. Yeah. Okay. Yay. Good job, Evan. Please do not dab in my class. All right. So, yes, Jason Little. Don't dab in my class. Okay. Okay. So let's go back and remember how the lipid bilayer is made. We have these green. The green parts out here are they are hydrophilic. Okay, they have polar ends. So if you remember the little squiggly up there in the purple is, in fact, I'll make it bigger for you guys. So let's do. Okay. All right. So the purples. Okay, these purple insignias are, remember that they mean partial charge. You guys remember that? It's a little delta. It's a figure 8 that doesn't quite finish.
Oh, yeah.
Okay, this figure 8 that doesn't quite finish, it's got a plus next to it, means that these parts to the these parts aren't they have a general charge on. It's not, they don't have, like, they haven't lost electrons to make a positive charge, but there's actually amino part. Amino doesn't mean much to you. They have nitrogens with 3 hydrogens sticking out. And the hydrogens, because their bond, the electrons in their bond are consumed by on the nitrogen side, we have these protons that are sticking out along the outside of the molecule. And same thing down here. And what that does is that makes it somewhat polar, that there's this local charge to it, and that will allow water molecules to come up next to it and be attracted to those ends. These here in the middle, the pink things in the middle, are the lipid part, and they are hydrophobic. They're made of long chains of carbons and hydrogens, and they like to stay away from the water. Okay, and so when you get a whole bunch of these phospholipids together, okay, they naturally form into this bilayer, because we have these ends right here in the middle that don't like to be near the water, and the ends on the outside that do like to be in the water. And so they help each other. The ones that don't hang out with the water hang out with each other, and the ones that are stay with the water. Well, that has a lot to do with our new unit. Okay. So so if we get this out of the way, that brings us to these concepts are going to be important for us as we start exploring what our solutions are. So where do we start? And we're going to start with the idea of mixtures. Okay. And there are 2 major kinds of mixtures. There are heterogeneous and there are homogeneous. All right, a heterogeneous mixture. Let me find my other. Okay, with a heterogeneous mixture, has components. Okay, they have components that are visibly discernible. Components are visibly discernible. Okay, that means, and I made up this word, they are telem Okay, they are telemarpartable. Okay, if you look at a solution and you can see the different components with your eyes, you see that it is a mixture of stuff. It is a heterogeneous mixture. Okay, a good example of this could be a okay, chocolate chip cookie dough. If you look at chocolate chip cookie dough, you can see the chunks of chocolate in the dough. Okay, it is visibly discernible from the rest of the dough. Yeah? Okay. Or another example would be, let's say you take a bunch of gravel and you put it into some water. Okay, you dump the gravel into the water, you have a mixture, but you have a mixture of gravel and water, and you got the chunks in there. Or say you're making cement, okay, and you mix the water and the cement, and you got all the stuff that's in the, but you see the rocks in the cement, and you can tell that there's chunks of stuff in there that aren't part of the liquid, that aren't part of the solution. Okay, that is a heterogeneous mixture. Yeah? You follow me there? Okay. Yeah, by the way, if I'm drawing stuff, you guys should also probably be drawing it. Okay. One of the beauties of doing this on video is that you guys can go back and draw the lipid bilayer at another time, which you guys should do. In fact, that's part of your grading for your notebook when you hand it in at the end of the unit. You better have the lipid bilayer in there that I drew. Okay. All right, so that's water. If we throw water and gravel in there, then we get something that looks like this. And so you see a whole bunch of water. You'll see the difference between the water and the gravel. Oh, that is not what I wanted. That's the one I wanted. And all right, and so you have water interspersed between all the parts of the gravel, and you have, all right, so this would be a heterogeneous mixture. Now, if you have a okay, so instead of doing this, then let's say instead of just throwing gravel in there, we take some dirt. And we throw dirt into a bucket of water. All right, you throw dirt in, and you'll still see pebbles down. You'll still see pebbles down at the bottom of your bucket. You'll see stuff that didn't get mixed up with the water. But what you'll also see is stuff getting mixed up in the water itself. Okay, you'll start making mud, right? And have you ever been in muddy water before? You ever played mud volleyball? It's awesome. The water is, you don't have dirt at the bottom of the pit and then just a layer of water. It's the water above is dirty, and it has dirt dissolved in that water. So what would happen if we took this dirt, if we could throw this dirt into the water, okay, we let it settle, and then we take all of the gravel out? What are we left with? Yeah, we're left with brown water, right? Okay, but you can't tell. It's just brown water, right? You can't really see the parts that make it brown. And that is when it becomes a homogeneous mixture. Okay, and a homogeneous mixture or where the components Okay, the components are not visibly discernible. Okay, you can't tell them apart. Okay, kind of like coffee. Okay, you make coffee, right? You run water through the coffee grounds. The reason the filter's there to take all the solid stuff out, or all the big coffee grounds. But when the water goes through the coffee pot and goes through the grounds, it comes out black, right? Okay, why? Because there are dissolved solids in the water, and you can let your coffee sit there, and some of the stuff that goes through the filter might settle to the bottom, but it's going to be black, and you can leave that coffee on your counter for, days, and it's still going to be black, right? Okay, so that's where that would be homogeneous mixture, and not only that, but if you get it to the point where it'll stay black forever, that, okay, is where we come up with what a solution is. I'm running out of black ink. No bueno. Okay, so solutions are homogeneous mixtures. And so we have certain properties to our solutions. All right, so solutions are homogeneous mixtures. All right, and they have certain properties. Okay, property of solutions. Okay, the particles dissolved. Okay, the particles that are dissolved are very small. Okay, they're evenly distributed. Okay, and they will not precipitate. So you guys remember what a precipitate does? Okay, we did that with our lead chromate. That when we made the lead chromate, it created a solid and eventually settled to the bottom of our solution. That is a precipitate, and that's not what a solution will do. If it's part of the solution, it will not precipitate. It'll stay in the solution. All right, so let's talk about the parts of a solution. All right, so we've got this. So I want you to take a look at this drawing. I want you to tell me which of these particles is the most abundant. Okay, the blue. There's more of the blue than the orange, right? Okay. Because that is the most abundant. Yeah, let's get our. Because it is the most abundant. I'm going to move this over here. Okay, because the blue particles are the most abundant, okay, they're called the solvent. Okay, so it is the light blue part in our drawing over here. Okay, that's the solvent. It is the most abundant. Okay, what the stuff is dissolved in. Okay, it is really the best definition that I can come up with. It's what the stuff is dissolved in. Okay, the other one is the solute, which I will make. Okay, which is a triangle in our drawing over here. Okay, that's the stuff that dissolves. So we have two things. We have what the stuff is dissolved in, and we have the stuff that dissolves. You could think of this in terms of like salt water. So imagine salt water. Okay, and this is my mnemonic for it. This is just how I remember which one's which. Okay, salt is the solute. Okay, and the water is the solvent. And you have to say with the accent for it to work. Okay, in order to get the V for the W, right? Okay, so it is water, that is the solvent. Okay, so you can remember it however you want, but that's how it's always worked for me. Okay, the most abundant. Okay, the most abundant substance in a solution is the solvent. Okay, so whichever one you have the most of, that is your solvent. Everything else are your solutes. Okay, and there can be only one. There can be only one. All right, there can only be one solvent in your solution. Everything else is a solute. All right, which brings us to solute versus soluble. Soluble versus soluble versus insoluble. Okay. When a solute does dissolve in a solvent, it is soluble. All right. When a solute does dissolve in a solvent, it is soluble. Okay. When it doesn't, it is insoluble. Okay, so salt, for example, okay, oil is insoluble in water. Right. No solute. Okay, no solute will dissolve in all solvents. Okay, for example, salt does not dissolve in oil. Okay, and no solvent dissolves all solutes. Now, you may have heard that water is called the universal solvent. Okay, this is a misnomer. All right, it's called a misnomer. And I'm just going to leave it at that. Okay, and I'll let you guys figure out what a misnomer is on your own. Okay, that's it. Introduction to solutions. So your homework tonight is through the stop sign at the end of page 3 in your new handout.